In this problem, we're given two functions, f and g. We're given f as a graph, g is a table of values. And we're asked to evaluate f and g for several variable values of x, and then subsequently add, subtract, multiply, or divide the results. So before I begin, let's remind ourselves the relationship between function notation, a table, and a graph in terms of what's the input and the output. In function notation, it's always the case that we write f of input equals output. If you're looking at a graph, since a graph is nothing more than a set of infinitely many points, you could think of converting function notation back and forth between ordered pairs, which has this as the convention, where the first coordinate of the point is the input, the second coordinate of the point would be the output. Since g of x is given as a table, I'm going to look at the notation x and notice that x is in the parentheses here, so they're saying x is the input. G of x is the notation for the output of g. So in each problem, it's just a matter of identifying the input and the output, but with different given information. So for example, the first question, f of 1, if you were to write it up here, you'd notice that if I wrote f of 1 on top of the general notation, it's basically saying that 1 is the input and I'm supposed to find the output. Since f was given to me in graph form, I'm going to look at f of 1 as a point, and they said that the input's 1, so in terms of a point, that would be my first coordinate. So on the graph, I'll find my output by simply saying, since x is 1, I need to move over 1 unit in the x direction, up or down until I hit the graph. In this case, the graph is up here. And I look at that point, and I label it 1, 3. The fact that 1, 3 is a point on f means that f of 1 is 3. In math, if two things are equal, you substitute one for the other. So where I see f of 1, I'm going to replace it with 3. And then I'm going to add it to whatever I get when I find g of 1. Just be careful that g isn't the graph, it's the table. But the notation hasn't changed. Whatever's in the parentheses is the input. So I need to go to where the input is 1. You have to be careful because there's actually two 1s in the chart, but I want the one that appears as an input. So since my top row is my input variable, I go to where x is 1, and I move down to the output, and notice that if you plug in 1, you get out 5. So the table says if the input's 1, the output would be 5. So I'm just going to move over and make the substitution where I see the notation g of 1 in the question. I'm going to replace it with 5. Now let me remember that my final answer will be 8. I need to clear the screen to give myself room to write for the next problem. And then I'll write f of 1 plus g of 1 was equal to 8. In Math AS, since they've already written the question, I need only have to write 8 in the blank. But remind yourself, if this was a homework problem or a test, your teacher would want you to actually write the problem out, stating the original equation, or question, f of 1 plus g of 1, and then write down what you found as an answer. It's f of 1 plus g of 1 that's equal to 8, not anything else. The second problem is just a repeat of the first, except note that g comes first, and then I'm supposed to subtract f. So I'll be using the table, then the graph to find the values of g of 3 and f of 3, and then simply subtract the results when I'm done. G of 3 says that 3 is the input, and I need to go to the table and make sure that I find the 3 in the chart that appears in the input row. And if you look over here at the input of 3, you get an output of 1. So therefore g of 3 is 1. So I'm going to put a 1 down here where I see g of 3. Now I need to subtract whatever I get when I find f of 3. Since f is a graph, I'm going to look at this as a point, but 3 is still the input. So it would be the first coordinate of the point in question. So I'm going to go to the graph of f, move 3 units in the x direction, move up till I see the point on the graph. If I had to label that point, its coordinates would be 3, 2, meaning that in function notation, f of 3 equals 2. Again, it's always f of input equals output. So where I see f of 3, I write the number 2. Since I'm supposed to subtract, 1 subtract 2, I get negative 1. So the answer to the second question is negative 1. In Math AS, you could simply just type in negative 1. Again, if this was a homework problem or a test, you should write the original question and your final answer like it shows here, indicating what you've found. I'm going to do f of 4 times g of 4 the same way. The only difference is I multiply my answers instead of add or subtract. Since I'm supposed to find f, and f is a graph, again, I'll look at that as a point. So my first coordinate's 4. My job is to find out the second coordinate to find out the output here. So I go to f, I move 4 units in the x direction. Notice I don't have to move up or down until I hit the graph. That means I'm actually already on f at the point whose coordinates are 4, 0. The fact that 4, 0 is a point on the graph of f means that f of 4 is equal to 0, which means I can replace f of 4 with the number 0. In fact, I don't even have to find what g of 4 is, because 0 times anything is 0. But for good practice, I'm going to find g of 4 anyway. So g of 4, since g is a graph, I just have to make sure I'm looking at the right one. Now, in this particular example, you can't get it wrong because, because the way the 4s are lined up. But just to be sure you make sense of this, because the 4 is in the parentheses, and in general we put the input in the parentheses, that I'm looking for the 4 in the chart that appears as an input. So I would be looking for where x is 4 in the top row, moving down. Just by happenstance, it happens to be the number 4 in this problem. This is one of those problems, I guess, if you do it backwards, normally you'd get it wrong, but in this special case, you'd actually get it right, because you get lucky. So g of 4 turns out to be 4. 0 times 4 is 0, so the answer to the third problem is 0. The final answer will be no different, or the last question, I mean, will be no different than the previous 3, except for I had to divide my results at the end. So this was 0. G of 5, I think you probably get the hang of it by now. Whatever's in the parentheses is the input. Just make sure that you find the 5 in the chart that appears in the input row. X is always the variable for the input. G of X is the notation for the output of G. So when you go to the chart, notice there's a 5 here, there's a 5 there. Be careful, I want the 5 that appears in the input row. So go all the way up here to where the input is 5, and notice that if you plug in 5, G outputs 0. So G of 5 is 0. So I'll put a 0 in my numerator. Again, 0 divided by anything is 0 in math, so I don't need to find f of 5. But I think it's good practice to find it anyway. Since f is a graph, I'm going to change the function notation into an ordered pair. What's in the parentheses is always the input, and in a point, that's the first coordinate. So it says on the graph, move 5 units in the input direction, then move either up or down until you hit the graph. In this case, I move up, so I hit this point right here. Imagine labeling the coordinates of that point. It would be 5, 4. Again, the fact that 5, 4 is a point on f, by definition means f of 5 equals 4. They mean the same thing. If the input's 5, the output's 4. So I get that f of 5 is 4, but as I said before, 0 divided by anything is 0. So my final answer on the last question is simply 0. Just kind of erase some of this stuff to clean things up. And this is what you'd be typing into Math AS. Again, if this was a workout problem or homework problem, you probably would have to write the left-hand side yourself and the right-hand side to get full credit.